Last week, we finished up with velocity and acceleration, and one of the very last things we did was a lab about reacting to gravity. We talked just a little bit about how gravity makes things fall. Gravity makes things fall faster as they travel through space or through air. And today we're going to go a little bit further with that idea of gravity being an acceleration, but we're also going to add the idea of gravity being a force. Gravity is a force that causes two masses to accelerate towards each other. This is going to be the first force that we learn about, and that's actually what our next chapter or our next unit is going to be, all about forces and the laws that control them. So gravity is a force that causes two masses to accelerate or move faster towards each other. The smaller object's acceleration is more noticeable, and the larger object usually looks stationary, meaning it looks like it doesn't move. So last week when you dropped your meter stick, the meter stick was the smaller object, and it looked like it moved. And the Earth would have been the larger object, and it looked like it didn't. Here are a couple other examples. There's a traditional story about a scientist named Isaac Newton, and he is credited with some of the very basic laws of physics, and also credited really with the idea of what gravity is and what goes up must come down. And supposedly he came up with this idea by laying under an apple tree, and an apple fell and hit him on the head, and he says, "Aha! What goes up must come down." Another example of gravity, or the effect of gravity, would be how the moon travels around the Earth. You may have noticed that throughout a month or so, the moon appears to change in what it looks like. And it looks different as we go through the month because of the amount of the lighted side of the moon that we can see. That's because the moon goes around the Earth. It's the Earth's gravity that keeps it doing that. The same is true for the Earth going around the sun. This is a lot of the reason why we have seasons, because the Earth travels around the sun and the sun shines on different parts of the Earth differently, but it's the sun's gravity that keeps the Earth doing that. So one of the first things we need to know to really understand gravity and how it works is that gravity is a force and also an acceleration. Forces are things that cause objects to accelerate, like a push or a pull. Acceleration, we should already know, acceleration means that speed increases either in size, like the apple, meaning that its speed got faster as it fell, or by changing direction, like the moon going around the Earth. The moon doesn't go around the Earth faster all the time, it just changes its direction. The acceleration due to gravity has been measured to be 9.8 meters per second squared. The symbol for that is usually a lowercase g, although you could use just our acceleration symbol, which was a lowercase a as well. What this means is that for every second an object is falling, a mass's velocity, or the object's velocity, increases by 9.8 meters per second. Every second that it falls, it goes 9.8 meters per second faster. If you change that into units we're more familiar with, that means every second that an object falls, it goes 22 miles per hour faster. And eventually, if it falls long enough, it reaches that idea of terminal velocity, which means it just can't go any faster anymore. But that's a little bit beyond the scope of the class. We do, however, need to talk about the difference between weight and mass. In our everyday speech, we use these words interchangeably. They kind of mean the same thing when we're just talking in our normal vocabulary. Our weight, or anything's weight, however, when we talk about science, is how hard gravity pulls on our mass. Our weight depends on gravity. But if you have more mass, then gravity is going to pull harder on you, so you have more weight. So the two ideas go together, but we need to know that mass does not change with gravity, and weight does. For example, if you were an astronaut and you went to the moon, you would weigh less. You would feel like you weighed less on the moon than you do on Earth. That's because the moon's gravity is less. Weight depends on gravity. So if the gravity is less, then your weight is less. But your mass, in other words, your body, has stayed the same. When you put on a spacesuit here on Earth to try it on, make sure it fits, it still fits when you get to the moon. They don't have to resize it because your mass or your body has stayed the same. But you feel like you weigh less because the moon's gravity is less. We also need to know that the distance between masses or between objects can have an effect on gravity. It can change how hard gravity is able to pull on those two objects. The further apart those masses are, the less force is caused by gravity. This is kind of like magnets. If you hold two magnets really far apart, they don't exert much force on each other. But if you hold them really close, you can feel that pull. You can feel the two magnets attracting. So the further apart the masses are, the less force is caused by gravity. But this is really only noticeable for very large distances. We're talking about things in outer space, like planets, stars, galaxies. You don't really notice the distance having an effect on gravity here on Earth. If you went up to a really tall mountain or got really high up in a plane, you might be able to tell a little bit of difference if you had a sensitive enough piece of equipment to measure it. But for the most part, we don't notice a difference in gravity here on Earth just with small objects. It's really only for larger, much further apart objects like planets and stars and galaxies. Okay, that's it for the notes today. Please make sure you have filled in everything on your packet so you can get your stamp. And there is a worksheet to complete after you are finished.